Okay, so today we're going to be talking about this idea called the Pythagorean theorem. You can see it's at the top of your sheet that you should have got from the sub right now. But this theorem that we're going to be talking about is we're going to spend about a week on this. It's going to be very short, and it's going to be a lot of applying. And this is something that a lot of people do use. You might not realize that it's involved in stuff, but I have had experiences where I needed people to be able to do this, and they could not, and especially when I worked at Menards in the construction. I had so many people that came up and asked me about different things, like they were trying to find the side length of their house and they couldn't find it, or or the length of a sidewalk or something when I did construction for the city of Des Moines or anything like that. We use this a lot in those fields, and those are just a few examples. So that's what we're going to get into today. So what I want you to do right now is you're looking at this sheet. It's called Pythagorean Theorem Discovery. We're going to discover what the Pythagorean Theorem is today. So what I want you to do is you're looking at this part that I have on my screen you're seeing on your paper. So I have all these triangles, and these are all right triangles, by the way. Okay? All these are right triangles. Remember, a right triangle you can put in that corner. There's those little 90-degree angles, all right? So what I want you to do right now, and I have all these represented by, I have one being the emoji, one being I can't say that word, and one being like this word. Okay, they're all different things, and they line up. What I want you to do is I want you to find how many tiles, so how many square lengths are each of those squares. So for the emoji, I want you to do, for the party emoji, I want you to, for I want you to figure out how long is that side length. And then I want you to find the area of the square. Remember, area is the total number of tiles in that square. Okay? And I want you to do the same thing for side length B, and then the area for B, and I want you to do side length for C, and the area for C. Now I want you to do all three of those triangles, okay? So I want you to do that right now, and go ahead and pause the video. Okay, so I went ahead and wrote in all the side lengths of all the squares. So now that you're resuming, you should be seeing that. So I'm going to go ahead and write in the areas. So we should have had 9. I'm going to write these all in red. This one should be 16. This one should be 25 for the party emoji. And then for the next one, we should have 25 for the area of square A, 144 for the area of square B, and 169 for the square root, or for the area of C. And for the sword at the end, we should have 64, 36 for B, and 100 for C. Alright, so now we're going to use all those, okay? So now that we see all those, what I want you to do is now, for each of those that you have in the next part on this page, for that triangle, using the same emoji, because that's how we're going to distinguish, for the same emojis, I want you to take the area of square A and add it with the area of square B in the middle column. And then I want you to write in the area, and then I want you to take for the same one, write in the area of square C. And I want you to compare the area of square A and square B that you added together to the area of square C, and see if you notice anything. And whatever you notice, go ahead and write that down below and says, what did you notice? So go ahead and pause the video and go ahead and do that. Okay, so I went ahead and filled it out now. Okay, and you should have this. You should see that the area of square A and square B is the same as the area of square C. Okay, so if you add the area of square A and square B together, that is the area of square C. And it's the same for each of those. So that's what I would have wrote here, is the area of, so if you add the area of square A, so adding, I'm not going to write it out, adding the area of square A plus the area of square B will equal square C. So that's what we should be seeing here. When you add those together, they should be the same. Okay? So this gets us closer to this idea of the Pythagorean theorem. All right? So, as you can tell, we went ahead and we found that based off these, remember, these are all right triangles. These were for right triangles, okay? So we had the side length 3, the side length 4 for the first one for that party emoji, and that was the side length of 5. We found the area of A and B, which are the legs, okay? And we found that those areas added up to the area of square C in this case. All right. So now, using the findings that we had from just on the other side, so I want you to flip your page over, and this should be the top problem on the next page. Say, okay, so I have a right-angled triangle, has side lengths 8 and 15 this time. I want you to use your findings from the other side, okay, knowing that if you have the two sides of a triangle, of a right triangle, okay, what would the length be, or what would the area of this square on the third side be? Which is along the hypotenuse, okay? And when the word hypotenuse means the side opposite of the 90-degree angle. All right, so when I say side opposite of 90-degree angle, that means Find your 90-degree angle. If you draw an arrow to the side opposite of it, okay, that is the hypotenuse, okay? So that would be our side C here. This is side C. So I want you to find the area of the square that would be drawn along the hypotenuse, and then I want you to find the side length of that triangle, okay? Or that side length of that hypotenuse. So how long would that side be? How long would side C be? So I want you to pause the video and go ahead and try that one. Okay, now resuming this video, okay? Using what we had known before, we know that if we find the area of the squares on the other side, so if I make a square on both sides of the triangle, we find the area of each of those squares, okay? It should add up to be the same area as the other one. So if I take the area of, find the area of the side length 8, so that'd be 8 squared, okay? 8 times 8 is 64, okay? That's the first one. So this one has an area of 64. For the next one, we'd have 15 squared. And 15 squared is 225. Okay, so this one is an area of 225. If we then take these two numbers and we add them together, so 64 plus 225, okay, that gets us 289. All right, 289. And then that is the area of the side C. That is the area of side C. Okay, so now that we know the area of this one is 289, okay, the area of that one is 289, remember, to find the area, it is length times width, okay, which in this case is C times C, okay, which C times C is C squared. So we need to figure out when is C squared equal to 289. Okay, and when we do that, remember, we got to get C by itself. We can do the opposite, squaring something, which is taking the square root. So take the square root. So we then have C equals square root of 289. You have a calculator for that. Is 17. Now we don't have to worry about the negative here because the negative, it doesn't make sense to have a negative side length. So our area is 17 now, or the side length of C is 17, but we can't forget a label. This is 17 centimeters. All right. So that is how long side C is. So this is the idea of the Pythagorean theorem. If we do not know a side length, we can find that side length by using this idea of the area of the squares on each side to then find the area of the third square, okay, and then we can go backwards to figure out how long the side is, because we know it's C times C, so we just got, or whatever, it's the same number times itself, so we just got to do the square root of whatever that area is combined together. All right, so that's what we're going to get into today. That's what we're going to be getting into. So the question is, here's the actual definition of the Pythagorean theorem, so please write this down. The actual definition of the Pythagorean theorem is, if a right triangle, okay, this has to be a right triangle. It cannot be anything else. If you do not have a right triangle, this will not work. Okay, if a right triangle, then a squared plus b squared equals c squared. And now, when I mean a squared, a and b, okay, a and b are legs, okay, and legs are the sides that make the 90-degree angle, okay. Sides making 90-degree angle, so that the two that connect there, and then C is the hypotenuse, okay? C is the hypotenuse, so I gotta make sure I spell that right. Hypotenuse, this is a hard word for me to spell, okay? And C is the hypotenuse. So what some people will also remember this is, as leg squared plus leg squared equals hypotenuse squared, okay, and they'll abbreviate like HYPT or something like that, okay, or OT. I'm going to spell it all out. Hypotenuse squared. That's how some people remember it. That way they don't have to remember the letters, okay. But so if you hear me say leg squared plus leg squared equals hypotenuse squared, it's the exact thing, same thing as a squared plus b squared equals c squared. All right. So I'm going to do an example here for what you're going to have to do next. So before we're going to really get into finding side lengths, we're going to just be asked to figure out if a triangle is a right triangle. So this works both ways. If we know it's a right triangle, we can figure out a side length. But if we don't know if it's a right triangle, but we have all the side lengths, we can figure out if it is a right triangle. So we can go both ways on this theorem. Okay? So here's my first problem. I have 3 for the side length. I have 7 and I have 8. All right? So 3, 7, and 8. Now, before I even get at that, I should mention the hypotenuse. If we go back to the very beginning and we look at the hypotenuse of all these triangles, so all the C's, okay, every single C, you will notice out of every one of those triangles, the hypotenuse is the longest side. Okay, so like 3, 4, 5. 5 was the hypotenuse. 5, 12, and 13. 13 was the hypotenuse for side C. 8, 6, and 10. 10 was the hypotenuse. That's side C. Okay, so the hypotenuse is always the longest side no matter what. So whenever we see something and they're like, is this a right triangle? Well, your longest side is going to be your hypotenuse. Okay, so I'm going to go ahead and we're going to determine. Okay, the question is this a right triangle? Okay, that's what we're trying to figure out. And so we can use the Pythagorean theorem to help figure this out. So our legs here, okay, our legs are going to be 3 and 7, and our hypotenuse is going to be 8. 8 is the longest side, so 8 is our hypotenuse. So when we do this, we can think of that leg squared plus leg squared equals hypotenuse. Okay, or if you want, you can think A is 3, B is 7, and then that means C, which the hypotenuse has to be 8, okay? So I'm going to go through, I'm going to use the leg squared, so our legs are 3 and 7, so I'm going to say 3 squared plus 7 squared. And then the question is, though, if this is a right triangle, these are going to be equal to each other, because these are the areas. We're trying to figure out the area of each square and see if they add, oops, that's a bad square. We're trying to figure out if each of these areas will be equal to each other. If we add A and B up, or the legs up, okay, it's got to be equal the area of C. So that's what we're trying to figure out. That's why I put a question mark here. So then I have 8 squared. So 3 squared is, now you just solve, 3 squared is 9, plus 7 squared is 49. And our question still is that equal sign, that's why I put that there, is 8 squared, which is 64. So now 9 plus 49 is 58. So ask yourself, is 58 equal to 64? That is not true. That is a big fat red X. Okay? So is this one a right triangle? I would say no. It is not a right triangle. Okay? And the reason why is because the Pythagorean theorem does not work. And we know the Pythagorean theorem will always work if it's a right triangle. Okay? If the Pythagorean theorem does not work, it's not a right triangle. That means it's either obtuse or acute. Okay? And we're not going to go into that stuff, but we're just going to be figuring out if it's a right triangle. So let's do one more here. Okay? Let's do one more here. So here, now, this time I'm not even going to make the triangle. I'm just going to give 3 side lengths. So let's just say we have 6, and let's say we have 8. Nope, sorry, not 8. Sorry, I want to change this. My fault. I should have had this planned out in advance. Let's make this 9, and let's make this 16, and let's make it 25. Okay? 9, 16, and 25. And we'll find out. So let's ask the same question. Is this a right triangle? Okay? That's what we're going to figure out. Is this a right triangle? Now, I make a triangle because I don't want to write it all out. That's just me. That's just a geometry thing. Okay? So same thing here. We got to determine the legs. Our legs are going to be our shortest side, our shortest 2, which are going to be 9 and 16. And the hypotenuse, okay, for this problem is going to be 25. So now when we do this, we're going to ask 9 squared plus 16 squared. Is that equal to, that's the question, is that equal to 25 squared? Okay, 9 squared is 81 plus 16 squared, this is why you have a calculator, 16 squared is 256. Okay. And is that equal to 25 squared? And 25 squared is 625. All right. Now, 81 plus 256 is 337. So is 337 equal to 625? No, that is not. So is this a right triangle? That's our original question. No, this is not a right triangle. Okay? That's all I have to say there. No, not a right triangle. Because, if you want to explain why, because the Pythagorean theorem does not work. That's the explanation 1. All right, so now what I want you to do is at the bottom of your paper now, you have these set of problems, okay? I want you to use the Pythagorean theorem to determine whether these triangles are right triangles, okay? Make sure that after you get it completed, you're checking with the answer key on Canvas, and then making sure you're submitting a photo to the Canvas assignment as well. And then please watch that final video over some history of the Pythagorean theorem as well. If you have any questions, please let me know. I'll give you my email and everything like that. Have a great rest of your day, and I'll see you tomorrow.